So a few words about me. I'm Director of Technology at CGTrader. I've been working for over 10 years with 3D, VR, AR, pipelines, automation, data visualization, and essentially anything interactive. I'm also a contributor to Kronos Group working groups, 3D formats, eCommerce, and the task subgroups, tooling and asset creation with Max. So without further ado, just a few words about CGTrader. So my company, or the company I come from, and why we think we are good people to talk about scale. We have a huge marketplace with over 6 million users and 1.5 million stock 3D assets, and we have worked with over 200 Fortune 500 customers on custom asset creation pipelines, and we have over 9,000 verified designers, community of designers that can create custom assets on demand for our customers. So we feel with these numbers we can, it's fair to say we can talk about scale. So need for scale and why it's so important in e-commerce. So of course, if you think about XR, AR, VR, metaverse, whatever, the key component is 3D assets, right? But if you're creating a custom scene, custom experience, you probably are focused on a small scene, or even if it's a big scene, it's still nothing in terms of numbers in comparison to huge online retailers or product companies or conglomerates that produce tens of thousands products yearly. That's why this topic is so crucial in e-commerce. So if you think about how the delivery process goes, whether it's a small studio approach or one company or huge retailer, the basic flow is somewhat the same, right? So you have the creation process, then you have QA, maybe then you have CQA, and then your asset goes to delivery. However, if you think about some changes in the mindset, in the technical approach, you need to adjust to be able to make this process actually time efficient and cost efficient. So these are 4 points. I'm not going to go one by one. I'll just talk about them in general because we're kind of low with time, and yeah. So I guess the biggest mind shift is from project management to process management. So if you're thinking about how agencies work and how do you create custom projects, right? You go to an agency, you say, hey, I need 100 assets. They need to be created with those specific requirements, and that's great. But if you're an online retailer and you have tens of thousands of those assets, you have multiple companies and you have multiple asset vendors, or you're a big product company or conglomerate like, I don't know, BSH, right? Bosch Siemens Group, they have 14 brands, then you have to, or in my opinion, you should shift your mindset, because then it's no longer a viable approach. You kind of need to build essentially factory assembly line of your assets and streamline the production so that when your artists or 3D artists or designers work on your assets, they don't think, hey, I'm working on this project, I have to focus on these requirements, and now I need to shift my mindset, I have to learn something else to do something else because those 50 assets have different requirements. No, you need standardized inputs, and you need just one process so that the artists get like this seamless experience. Whatever they work on, they know what they work on, right? So that's like small intro to kind of mindset shift. So in the perfect case scenario, we'll just have like one flow for creation, one flow for QA, and automation does all the rest, right? It's not always perfect, it's not always possible, but we're trying to do it this way. So now I'll take you to 2 use cases where standardization and technical approach helped us solve some challenges, and in the end I'll tell you what were the results of those things. So in first case study, this was a furniture company that produced with us over 20,000 assets for their retail e-commerce website, and they required multiple deliverables. So if you think about kind of old school approach, you need images, like high-res images, maybe you need a 360 spinner, you need high poly offline deliverable, but you also want to have real-time assets. So in this case, I know this is a bit confusing maybe, but on the top left you see the max plus V-rate, so the source asset that our designers were created, and essentially everything else was automation. So when they created this asset, according to the technical requirements, we did some automated validation. We delivered the max file. We delivered the renders. We delivered renders with real-time, so like white style renders and the lifestyle scenes renders and 360 spinners. But then, if you look a bit lower, we went to max to FBX. So we wanted to transition to an authoring format or transmission format that could be then converted into real-time assets, then converted into to GLTF from FBX, and from that point onward, we again have to validate and then convert for different platforms. So the company had their own proprietary viewer that had different technical requirements, but they also wanted to host their assets on big tech company viewers like Spark AR, for example, and all those players have bit different technical requirements. And of course, going through this manually and making people to do one by one, convert one by one, and make sure all the technical requirements are met, it's almost impossible and super tedious task. So we had to build this modular pipeline. There are, of course, different transmission formats that could be used. In our case, to play into this idea of having this assembly line, we wanted to use FBX as a geometry standard and then PBR texture set separately, because this is how we deliver our real-time assets. So we just combined our two workflows into one automatically, and that's why we decided to go for this. And this way, designers that were working with us, they didn't have any friction when switching from project to project. They were already used to this workflow. And in this case, like, these are two examples. So these are two extremes. One is high poly offline render, and the other is real-time AR app. We delivered way more deliverables for this use case. However, I just want to show two extremes, and they're all created just with one source asset, right? In this case, we created 10 different deliverables, so different 3D formats or renders or 360 viewers with just one input provided by designers, which saved us approximately 75% time, hence the cost. This is, of course, approximate number, but we try to estimate it as good as possible. In the second case, we also had a project where we had to deliver assets with a lot of complex technical requirements and a lot of LODs. However, those LODs had to be also game engine ready, so they also had to have good topology, etc. And there were a lot of consistency issues. So, for example, slight mismatches in UV islands amongst the LODs, or some other technical inconsistencies that caused CQA, so the client customer review, to fail over 16% of assets, which, again, if you're delivering 10,000 assets a month, this is a huge number, and this is a huge money, and this is a huge cost to reiterate, right? So in this case, we just provided a tool for designers with automated checks. This is a kind of fake example. I mean, like, this is just a dummy example, how it works. But the idea is we don't validate the assets only when you upload them to our platform. We actually provide the tool for designers that when they work, they can seamlessly see if they're working correctly, if they're fulfilled all the technical requirements, if all the consistency is met, etc. So this way, the production is seamless. There's no feedback loops on technical requirements because they constantly see what they're doing good or wrong. And again, in our case, when we work with thousands of designers, this is also an educational value for them because they know how to create assets according to good standards. And again, in this idea where we're talking as a designer, you shouldn't be thinking what project you work on. You should just work on projects. In this case, you load your asset with the requirements, you just work on it, upload it through your DCC, so you don't even have to, leave your DCC and work on another one. So it's essentially streamlining the production and making it effortless for the designers. By the way, this tool is specific to our platform. However, the checks we developed, we're going to open source this library, so we can create your own pipeline tools, or whether they're offline or they're for designers, you can just with Blender you can create your own based on that. It's not live yet, so you can just contact me. I can share you the link when we actually upload it to GitHub. And in this case, we reduced the CQA rejection from 60% below 1%, which again I do believe at this scale it's a huge improvement. And yeah, without further ado, I'll pass it on to Max, who will take you through more technical aspects maybe of the things I've been talking about on high level.
All right, cool. Yeah, thanks so much, Paweł. Yeah, as you said, I want to go a bit more into some of the details that were already mentioned, and just some quick info about myself and our company. So I'm CEO at DGG. I'm also co-founder of the company. Consider myself more a technical founder. I have a PhD in computer graphics originally, and also co-chairing the asset creation, 3D commerce asset creation group at Kronos. So we're also talking about GLTF later. And our software Rapid Compact is a solution that allows you to automatically optimize 3D models for e-commerce and other applications. It's also an API and available as an online version since 2020. This year we processed over 1 million assets for leading brands and retailers automatically. So that's also why maybe it's a good idea that we talk a bit more about scalability today. And then one really exciting thing is that Shopify just launched like an importer where all of their over 1.7 million merchants can upload 3D models, and if they are too large, they'll automatically run through Rapid Compact, our software. So we hope that this number of the 1 million assets this year goes up a lot as merchants are picking up 3D workflows more and more. So that's something that we're really proud of, and we're drafting a blog post. We are still waiting for the final imagery, but you can read more under this link already. And yeah, find me on Twitter or elsewhere if you want to get in touch. And again, like I would like to talk a bit more about some of the technical details that Paweł already like outlined. And one aspect that we've heard is converting models between different formats and specifically converting materials, right? So this is the first part I would like to go a bit more into detail. And if you think about materials, we have heard already offline and real time, right? We have seen an example, and this is yet another one where you see a scene in V-Ray, actually in 3ds Max using the V-Ray preview renderer. And this can be used to generate photorealistic imagery, right, for catalogs, so classical like offline renderer. And the material setup uses V-Ray nodes that are very specific to these offline rendering scenarios and not one-to-one translatable to real-time. So if we want to do this in an automated process, it takes a lot of work, a lot of engineering, and we're basically building a bridge between two worlds in order to get something out like, let's say, a GLTF model that uses physically based rendering according to the GLTF material specification and can run in the browser, right? So this is the aim. But as I said, this really means bridging two different worlds, going from the offline world to the real-time world. And it comes with a lot of challenges, of course. It basically means you go from a DCC-specific authoring format, like let's say a 3ds Max scene with the V-Ray renderer or Maya scene with the Arnold renderer or whatever it is, to a real-time ready standard. So you want to map everything to that real-time ready standard material model. And of course, you will not always be able to get a perfect translation that is lossless, right, per definition, because some things that happen in these offline renderers might not even be physically based, some might not be representable in a real-time renderer yet, and so on. But of course, you want to get the best possible result, and then even the QA process is a bit of a challenge because you need to make sure you have exactly the same lighting environment. So this is like a counter example where the lighting is different, and then it's hard to judge, is the gold like the same or is it just the light, right? So a lot of challenges to solve. And I would like to briefly talk about USD in this context, which you probably all know as one standard format for scene composition and exchange. So in contrast to GLTF, which is really like the JPEG for 3D and meant for downstream use for delivery, USD is more suited for upstream use, authoring, loss-free storage and exchange. Has been praised, for example, by NVIDIA recently, SIGGRAPH, who are really making a big bet on like USD and building a lot of technology on this, like the Omniverse solution. And then there's one particular thing that's interesting in combination with USD, which is the Material X format for materials, and it can be used in conjunction with USD for the scene data, right? And this is becoming very popular. So Material X by itself is again another open source project, and it's agnostic about the DCC, it's agnostic about the renderer, which is really good for the use case that we looked at, right? And it supports also various material models. So for example, GLTF PBR is just one new material model that was proposed. Standard surface is another one. Then there is the USD preview surface and so on. And these material models, once they are defined, can be translated using Material X scripting, for example. So you map them all to Material X, and then you can map between them, right? And that's a quite powerful approach, and especially encouraging because we see a lot of tools picking up like at least partial support for Material X and implementing it. For example, if you look at the Unreal Engine public roadmap for 5.1, it's also there. So I think that's a really promising path. And that's why we are also working on mapping data to Material X in order to get a renderer agnostic format that we can use as a high quality base asset. So much for materials, but then even if we have a model that has real-time ready materials or materials that we can directly translate to real-time, there are still some challenges that we have to solve when it comes to the optimization of the models. And one thing is the bandwidth requirements, right? So in e-commerce, you often really want to be able to load the assets really quickly in, let's say, ideally under 3 seconds or even under 1 second, depending on what the application is. And on top of that, you have quite different client devices, and you want to make sure that they always render fluently and that the user experience is nice, right? So that means for these reasons, you need to keep the file size low, and you need to keep the draw calls, poly count, and texture count low. And all of that can be done, of course, automatically through optimization. And yeah, we've looked in this topic a lot. That's our main focus, actually. So there are a lot of aspects to this, right? And everyone first thinks about polygon reduction, but that's actually not the hardest part. So apart from the meshing aspects, there are a lot of aspects related to materials and textures, like when do you bake an atlas? What do you do if you have tile textures? What do you do if you have support for 2 UV channels? Maybe you want to have like tile textures in the first channel for like patterns, and another one that uses global UVs for an AO map or something like that, right? So material handling is one topic, draw call reduction, then of course things like removing invisible interior geometry and things like that are all very specific to the application, right? If you think about like have a closet and you have some drawers, depends on the application if you open them or not. If not, you can remove the interior. If you open them, better not remove it, right? So a lot of different aspects around optimization. And I just want to show in the remaining time some examples from the furniture domain. We have already seen some from Paweł, and this is really an exciting area because these AR apps just make sense and they are just emerging everywhere because people can really see in their space how big a certain product is and if it fits physically, right? Not only regarding the style, but if it actually fits dimension-wise. And this is so much easier than measuring at home. Frankly speaking, no one does that, right? So here's an example from one client of us, Otto, and then also one from Target. And for Target, you can see that they have these buttons there in their web shop where you can see the item in 3D, AR, and in the floor planner. So these are already 3 different kinds of applications, right? And what people are then usually discovering is that they need all different, all kinds of different optimized versions for these different applications. And this picture is actually taken from the Kronos asset creation guidelines, so you can look it up and get the context also online. And what it basically says is each of these applications has potentially slightly different requirements, right? Paweł also mentioned Spark AR as one example. And that means you need to have an automation pipeline that allows you to bring one high-quality base asset with the real-time ready PBR materials automatically into all of these applications. And we have done this, of course, a lot, but here I just want to conclude with one nice example because you don't see that so often, I think, which is an LOD that has less than 44 kilobytes. And that's a version for instant loading. So basically like an AR object that you can directly place in your scene while the high-res version is loading in the background, and you can already, figure out where to place it and so on. And it anyway takes a bit till you have done that, and in the background the high-res version is loading. And this is a nice example because it looks reasonably close to the original, but it dropped all the textures, right? That's how it got so low. And so each application has a specific set of optimization parameters that really lets you get the best possible result for this particular use case. And that's actually a key message here. And Otto, our client who I showed before, with their AR app, for example, they're using this kind of technique. So with that, we have pretty much 5 minutes left. I think that's great. We're both trying to be fast enough so that we have enough time for questions. Yeah. Thanks.
Please go ahead.
Thank you. One sec with the questions so I can give you a microphone here. Hello. Thanks for sharing your project. And I have two questions. In your standardized workflow, what does your designer, 3D artist, start from while creating the asset? I mean, scans, pictures, or what else?
It depends on the client. In perfect case scenario, you would have always the same. You kind of need to come up with information framework. So regardless of the project, they should be working with the same input. However, it's not the case. Sometimes it's just images. Sometimes it's 3D scans. Sometimes just one image, and then a lot of verbal feedback, which is the worst, of course. So yeah, but mostly it's either scans or images.
Thank you. And maybe I missed it, but is the approval process managed by your platform as well?
Yes. So
the approval process by your clients, I mean.
Yeah, I didn't show that because we didn't have enough time, but we have digital asset management system where we have our internal QA team that has the tool when they can view the asset, view the references, and pinpoint all the issues, etc. in real time. And then if the client requires it, there's also CQA step, so client QA step, where they can also use our platform but tailored for their needs. Because, for example, not many clients have really technical details, so we can strip down all the technical stuff that has to be handled by us. And for them, it's usually about visual aspects, whether the color is exactly what they need, where the proportions are there. But we provide the tool for customers as well, if they don't have their own proprietary QA tool. So,
okay. Thank you.
Were there other questions in the audience?
I have a question, but I'm not sure if it's, I think, somehow related to the previous one. So when you are transforming like this original file to these formats, USD, Z, and the other one, GLTF, how did you validate that the conversion has been done correctly? Like that the lighting effects and like the colors and all that, it's maintained.
Do you want to take it? Or?
I can start.
Okay.
Maybe you can add on it.
Okay,
how
sure.
you do it. Yeah.
Like if you have it automatized somehow.
Yeah.
Like a check.
Yeah. I mean, what we do on our platform at least is that we render a 360 image, so we can see that, and there's an interactive 3D view. Now you can see the USDZ usually on the Apple devices if you use the AR function there. But that's something we're still working on, having like a more automated way of showing people the USDZ results so that they don't have to use their phone. But yeah, maybe.
Yeah, in our case, like if I would go back, but if I would go back to this diagram, after each conversion step, there's a validation step. So for technical requirements, we just rerun the checks. In terms of visual aspects, of course, there are some things that you can check automatically without, high-tech stuff like colors, for example. There are some ideas with using AI for comparison. We are working on it, but I'm not going to say this is like 100% out of production because it's not yet. So there is some visual, just human touch in the loop, right? But so whatever we can, we automate in terms of validation. We do it after each conversion step, so there's no, for example, that after mesh optimization, maybe something got overlapped, or there might be some issues. So we check technically whatever is possible, and then someone can also review it manually. But we're also working on automated solution for reviewing the image quality, but yeah, that's in progress.